Welcome to the Sleepy Cosmos channel, a place where science and serenity meet. Here we explore the quiet wonders of the universe, from dark matter to string theory, all told in a calm, soothing rhythm designed to help you relax, drift, and dream among the stars. Each video is a guided journey through the cosmos, slow, meditative, and filled with real science wrapped in gentle storytelling. So if you love space, curiosity, and the peaceful side of knowledge, you're in the right place. Make sure to subscribe for more new sleep narrations every week. And if you'd like to reach out for collaborations or business inquiries, you can contact us at the sleepycosmoschannel@gmail.com. Now settle in, take a deep breath, and let's drift into the universe together. In the quiet hours of night, when thought softens and the world outside has gone still, you may sense it, that subtle stretching of everything. Not a sound, not a motion you can feel, but a drift woven into the fabric of existence itself. Even as you rest, the space between atoms, between stars, between galaxies is expanding, slowly, silently, endlessly. This is not imagination. It is the gentle rhythm of the cosmos, an invisible breath, a universal pulse, carried by something we call dark energy. No one has ever seen it. No telescope has captured its shimmer, yet it moves everything. It is the calm hand pushing galaxies apart, the unseen tide that turns the future into distance. Astronomers first noticed its whisper at the end of the 20th century. They studied supernovae, brilliant explosions marking the death of ancient suns, expecting those lights to reveal a slowing universe. Gravity, after all, should pull everything back together, like breath drawn inward after a sigh. But the data told another story. The distant supernovae were dimmer than they should have been, farther away than the equations allowed. Instead of slowing, the universe was speeding up. It was as though space itself had begun to accelerate, as if the cosmos, once content to drift, had suddenly decided to flee from its own beginning. To explain this, scientists named a mystery: dark energy. Not because it is dark, but because it is unknown. A placeholder for something vast and silent, filling all of space, shaping destiny through absence. Imagine a force so smooth, so constant, that you cannot point to its source. It doesn't gather like clouds, or flow like wind, or shine like stars. It lives in the void, the vacuum itself. In every cubic centimeter of emptiness, in the spaces between atoms, in the gaps between galaxies, there lies an invisible pressure, a kind of cosmic tension that stretches reality outward. And though the name energy suggests fire or motion, this is not energy as we know it. It is the stillness behind all movement, a faint hum inside nothingness. For most of cosmic history, matter ruled. Galaxies formed from gravity's patient pull. Stars were born, burned, and collapsed. The universe was dense, bright, and restless. But as it expanded, matter thinned, light faded, and the subtle hand of dark energy began to dominate. Now, billions of years later, its influence is supreme. The cosmic web stretches, clusters drift apart, and the night grows deeper between the lights. Each second that passes, each breath you take, space itself grows by a fraction too small to notice. Yet multiplied across billions of light years, it becomes unstoppable. We call it the accelerating universe, but acceleration is only part of its grace. What we truly witness is persistence, the quiet insistence of existence to unfold without friction, without fatigue. It is as if the cosmos loves distance, as if the act of creation was not a single event but an ongoing expansion, a story still writing itself in every direction. And though we measure it in equations, in redshifts and constants and cosmic microwave backgrounds, beneath the science lies something softer, the hum of infinity, the hush between stars, the slow blooming of forever. Tonight, as you listen, you are part of that motion. Every molecule in you is carried outward on the same invisible tide. Your body, your breath, your heartbeat are expanding too, infinitesimally, like the gentle pulse of distant galaxies. The room around you, the air, the silence itself is woven into that same expanding fabric. When you inhale, you echo the universe's first motion, the moment when space itself began to grow. When you exhale, you release that motion into calm. You are not outside the cosmos. You are its continuation, its thought, its awareness folded into form. The mystery of dark energy begins, perhaps, not in equations but in wonder. How can nothing have pressure? How can emptiness move galaxies? How can silence contain force? In quantum theory, even the vacuum seethes with activity. Particles flicker in and out of being, borrowing energy for a breath of time before returning to the void. This restless sea of potential may be what we feel as dark energy, a storm so uniform that it appears still. Yet there are other ideas, other dreams scientists have dared to imagine. Perhaps dark energy is a property of space-time itself, a built-in curvature that drives expansion. Perhaps it is a field that changes over eons, slowly evolving like the faintest breeze across eternity. Or perhaps it is something our minds are not yet shaped to see, an echo from other universes, a resonance across hidden dimensions. No matter the answer, its presence is undeniable. It defines the future shape of everything, whether galaxies remain neighbors or drift beyond each other's sight forever. Consider this: if expansion continues to accelerate, there will come a time when even the nearest galaxies slip beyond our cosmic horizon. Their light will fade from view, and the night sky will become emptier until only our local stars remain. And after long ages, even those stars will die. The universe will grow dark again, bathed only in the glow of cold starlight and the echo of the Big Bang. But that far-off silence is not sadness. It is balance, the final breath in a cycle too vast to comprehend, a universe returning to stillness as it began. Dark energy teaches us something subtle, that motion need not be loud, that power can be patient, and that creation continues long after its first spark. When you close your eyes, imagine space not as emptiness, but as a gentle fabric breathing outward, a sea without waves, a rhythm without sound. Imagine galaxies as lanterns floating on invisible currents, their light stretching across ages, their distance growing yet their beauty undiminished. You are floating too, among them, a small consciousness carried by the same tide. This is not just physics. It is the story of everything expanding quietly, including thought and time and dream. The next hour will take you deeper into how we discovered this invisible motion, how we measured it, questioned it, and learned to live with its mystery. You will hear about the breath of the universe, the nature of nothing, and the serene tyranny of the force that drives forever outward. But for now, simply rest in the idea itself, that the universe is still unfolding, that even in silence there is motion, and that you, right now, are part of that calm acceleration, the hush that carries galaxies apart and dreams toward tomorrow. Let the thought linger. Let it soften into quiet curiosity. Let the sound of expansion fade into your breathing. For tonight, the mystery does not need to be solved. It only needs to be felt, like gravity turned inside out, a peace that expands without end. And so the journey begins into the dark energy enigma and the tranquil realization that even the emptiest space is full of wonder. The universe breathes, not in the way lungs rise and fall, but through the widening of space itself, a slow, eternal exhale measured not in seconds, but in billions of years. Every point in the cosmos drifts from every other point, not because of motion through space, but because space, the very stage on which matter performs, is stretching. Imagine a fabric, not woven from threads of cotton or silk, but from geometry itself. Galaxies are embroidered upon it like tiny sparks of color, and as the fabric expands, the sparks move apart, not by their own will, but carried outward by the growth of the cloth beneath them. This realization was slow to dawn. For much of human history, the heavens were seen as a fixed dome, eternal, unchanging, serene. Stars wheeled across the sky in perfect cycles, and the notion of expansion seemed as alien as the void itself. Then came the 20th century, a time when glass and metal turned curiosity into vision. Through the telescopes of Mount Wilson, Edwin Hubble measured faint smudges of light, spiral nebulae, as they were called then, and found that they were not clouds within our Milky Way, but entire galaxies, each receding from us at tremendous speed. The farther away they were, the faster they seemed to flee. It was as if every corner of the universe were pulling away from every other corner, like dots drawn on an inflating balloon. This pattern, the redshift of distant galaxies, became the first clear breath we ever detected. The cosmos, it seemed, was not static after all. It was alive with expansion. For a time, scientists believed this breath would slow. Gravity, the great gatherer, would tug on galaxies, gradually easing the outward rush. Perhaps, in some distant future, it might even reverse, a cosmic inhale leading to a final collapse, a big crunch that would end the universe as quietly as it began. But when astronomers measured ancient supernova, Type Y explosions, bright enough to serve as cosmic mile markers, the distances did not fit the prediction. The galaxies were farther away than they should have been. The expansion was not slowing, it was accelerating. That revelation transformed cosmology. The universe, once thought to breathe in and out, was now seen as exhaling faster and faster, its lungs limitless, its rhythm eternal. To picture this expansion, close your eyes and imagine a vast ocean of darkness. Upon its surface float countless lanterns, galaxies glowing softly, their light rippling outward through the sea. The lanterns do not sail, the water itself swells between them, carrying each farther from the next. No matter where you drift, the scene appears the same. Lanterns receding evenly in all directions, their glow dimming with distance, their silence unbroken. This is the Hubble flow, the universal recession that defines the large-scale structure of reality. It is not that we are at the center, there is no center. Every galaxy witnesses the same retreat, each one feels surrounded by the other's departure. At small scales, gravity resists. Stars remain bound to their galaxies, galaxies cling in clusters, clusters laced together into filaments of light. But beyond those filaments, the cosmic web surrenders to expansion. Void regions grow and galaxies drift into ever deeper solitude. Astronomers call the rate of this expansion the Hubble constant, though it is not constant at all. It evolves as the universe ages, changing with the delicate balance between matter's pull and dark energy's push. Early in cosmic history, matter dominated. Expansion slowed. But as the universe thinned, dark energy's gentle hand became stronger, and the great breath quickened again. Even now, we do not know why the breath has this rhythm. We can only feel its cadence through measurement, through the faint stretch of light, the subtle delay in time, the red shift that tells us space itself is moving. Light is our messenger. When a distant star shines, its photons travel through expanding space. Each wave of light is stretched, its wavelength lengthened like a sound losing pitch. By the time it reaches our eyes or instruments, the light has reddened, a cosmic Doppler effect revealing motion not through speed, but through geometry. The redshift is more than color, it is history encoded in brightness. Every photon we see tonight left its home when the universe was younger, when galaxies were closer, when dark energy's influence was faint. As we look farther away, we look further back, watching the cosmic breath in slow reverse, the exhale of creation frozen in light. It is humbling to realize that this expansion is everywhere, even here, within this quiet moment. Your atoms are bound tightly by electromagnetic force. Your feet rest on Earth's gravity. You feel still. But between the molecules of air, between the stars above, the same gentle stretching continues. It does not pull you apart. The forces that hold matter together are far stronger. Yet in the vast distances where gravity's grip weakens, dark energy's whisper becomes a shout, inaudible, invisible, but constant. That whisper is what we study when we speak of the accelerating universe. It is not chaos, it is order expanding. Not destruction, but continuation. Imagine for a moment that the universe truly breathes. Each second that passes is another heartbeat of expansion. Each billion years, another sigh of starlight fading outward. If you could listen with instruments tuned to gravity itself, you might hear it, a slow, deep pulse beneath everything, a low note resonating through space-time. The galaxies are the rhythm markers, their motions the music of distance. In that music, dark energy is the silence between notes, the space that allows the melody to exist. Without the silence, there could be no sound. Without dark energy, the universe might have collapsed under its own beauty. When scientists plot the data, redshift on one axis, brightness on another, they see a curve bending upward, a signature of acceleration. To fit that curve, they insert a term into Einstein's equations, a cosmological constant, symbolized by the Greek letter lul, lambda. Einstein once added lul to balance his equations, seeking a static universe. Later, when Hubble showed that space was expanding, he called it his greatest blunder. Yet now, decades after his death, that same constant returns. Not as a mistake, but as a clue. The lul represents energy inherent in the vacuum, a property of space itself. It tells us that emptiness is not truly empty, that the void possesses a density, tiny, uniform, and persistent, capable of driving galaxies apart. This constant is astonishingly small, yet over cosmic distances, its influence becomes infinite. It is the breath behind every star. Think of the Milky Way, our spiral home, anchored by a supermassive black hole. For billions of years, gravity will hold its stars in graceful motion. But beyond our local group, beyond Andromeda and its satellites, galaxies already drift away too fast for light to bridge the gap. Someday their glow will redshift beyond visibility. They will become whispers fading into infrared, then microwave, then silence. Our descendants, if any remain, will look up at a sky devoid of galaxies, believing perhaps that the universe ends where their telescopes can no longer reach. Only background radiation will remain, the afterglow of a creation long past. That is the destiny written by the current breath. Unless the rhythm changes, distance will win. But for now, we exist in a moment of extraordinary balance. The stars still shine. Galaxies still interact, colliding and merging like dancers meeting mid-step. Clusters form and dissolve. The cosmic web shimmers with motion. We are living within the breath, the midpoint between creation's heat and eternity's calm. To study the universe today is to listen to that breath in exquisite detail. We build telescopes that capture faintest photons, satellites that measure background radiation to 1 part in 100,000. From these signals we infer the rate of expansion, the distribution of matter, the subtle tug of dark energy. Every observation refines the rhythm, a more precise metronome for the cosmic symphony. Yet even with all our instruments, we do not truly see expansion. We sense it through math, through light delayed and stretched, through patterns imprinted across the sky. It is a presence detected by absence, a movement without motion. And in that paradox lies beauty. The cosmos does not rush, it drifts. It does not scream, it hums. It does not age in haste, it ripens like a wave unfolding across time. Each new discovery reminds us that we are breathing with it, a brief consciousness inside a long exhale. So when you rest tonight and your breathing slows to match the rhythm of sleep, imagine the same cadence echoed in galaxies. Imagine space itself expanding with every breath you take. No edge, no boundary, only the widening of possibility. For this is the breath of the universe, soft, patient, unending. The quiet miracle that carries all things apart, yet binds them together through the harmony of their motion. There is a quiet unity behind every expansion, an order so deep it feels like silence wearing form. Each galaxy, each star, each mote of dust follows the same invisible instruction to move apart, to drift, to make room. But what is space itself that it can stretch? What is the thing that grows? Imagine the universe not as an object inside a larger emptiness, but as the emptiness itself gaining size. There is no outside to move into, no boundary, no wall. When space expands, new space is born, not taken from somewhere else, but created everywhere, all at once. Every region of reality grows together, like dough rising from within, carrying the raisins of galaxies apart. This simple image captures a deep truth. Cosmologists call it metric expansion, the idea that the geometry of the cosmos itself is what evolves with time. If you could see this in slow motion, you wouldn't notice galaxies flying through a dark background. You'd see the background itself widen, carrying its lights outward, each one perfectly still in its own local patch of space. This widening is gentle, so gentle that during a human lifetime it is invisible. The stars above will hold their patterns for millennia, but on scales of millions of light years, the drift is relentless. The breath of the universe never stops. When scientists describe this process, they use a set of mathematical relationships known as the Friedmann equations. These come from Einstein's theory of general relativity, and they connect 4 main ideas: the energy density of the universe, its overall shape, its expansion rate, and the mysterious pressure of dark energy. In plain words, the equations say that the rate of cosmic expansion, often called h squared, depends on 3 main ingredients. First, the amount of matter and energy filling space, which tries to slow expansion through gravity. Second, the curvature of space itself, which can either bend inward or outward. And third, a tiny but constant energy built into the vacuum, which acts like a gentle push outward, the influence of dark energy. As the universe ages, these ingredients change in strength. matter thins as galaxies spread apart, curvature smooths toward flatness, and dark energy remains steady, becoming the quiet background rhythm that sets the pace of expansion. To measure that rhythm, scientists launch satellites like WMAP and Planck. They map the faint afterglow of the Big Bang, the cosmic microwave background, a soft radiation that fills all of space, only a few degrees above absolute zero. Within that whisper of light are tiny variations, ripples only 1 part in 100,000, that show how matter first gathered under gravity. By studying those ripples, we can reconstruct the history of the cosmic breath, how it quickened, how it slowed, and how it found the balance we see today. At first, light itself dominated. Radiation controlled the pace, its energy dense and powerful. Later, matter took over, slowing the expansion with its collective gravity. Now dark energy leads, a ruler with no throne and no form, governing through stillness. The proportions of these three, light, matter, and dark energy, shift like chords in an endless symphony. We live in the brief measure where they are almost equal, a moment of balance between gravity's embrace and the vacuum's quiet release. In myths long before science, creation was described as breath. In ancient texts, it was the wind of spirit. In Hindu cosmology, worlds were exhaled and inhaled by the divine. Even early poets felt that existence itself was motion between stillness. Science, in its calm precision, has circled back to the same vision. The universe is something that breathes. Each cosmic breath lasts billions of years, yet its pattern mirrors your own. Expansion, pause, release. As you breathe now, your chest rises and falls in quiet rhythm with galaxies receding beyond sight. Your heartbeat is a miniature echo of the accelerating cosmos. To study this is to accept humility. Our solar system is a ripple in an infinite tide. The Milky Way, grand as it is one among trillions, each guided by geometry rather than choice. Yet, from our small planet, we have learned to measure that geometry with exquisite care. It is a wonder that minds made of atoms can trace the motion of the atoms that made them. Astronomers often say the universe is flat. This does not mean two-dimensional, but balanced. In such a universe, parallel lines never meet, and the angles of a triangle add perfectly to 180 degrees. Too much matter, and the universe would have curved inward and collapsed. Too little, and it would have raced apart too quickly for stars to form. We live at the delicate midpoint, where expansion and gravity are in long equilibrium. It is this fragile tuning that has allowed complexity, and with it, awareness. The breath is balanced, neither gasp nor sigh, just continuation. If you could step outside time, you might see the universe as a flower in bloom, its petals of galaxies unfolding slowly, each carrying clusters of suns and worlds. From our perspective, that unfolding seems eternal. But even this rhythm may change. Dark energy could strengthen or fade. The breath may one day quicken or still. Physicists give names to these possibilities: phantom energy, quintessence, the big rip, the cosmic bounce. Each is another melody woven through the same universal song, what sustains the rhythm of existence. In its earliest moments, the universe expanded with wild speed, a flash called inflation, when space ballooned faster than light. Now, billions of years later, the pace is calm and deliberate. Cosmic history, when viewed as a whole, moves from turbulence to tranquility, from roaring birth to quiet maturity. The breath has slowed, yet deepened. And in that depth, dark energy reigns, a gentle, invisible pressure that fills the silence between atoms and stretches the gulf between galaxies. Far in the future, the pace will grow too great to cross. Distant galaxies will retreat faster than their light can travel. They will fade beyond all reach, leaving each surviving galaxy as a lonely island in an expanding sea. Even so, within each island, stars will still be born, planets will still orbit, and perhaps new beings will look outward, wondering at their isolation, and discover that they, too, are surrounded by expansion. Everywhere is center. Every observer witnesses the same outward drift. There is no privileged place in the cosmic tide. In a universe without edges, all points are equal, and all hearts beat to the same slow rhythm of space itself. Sometimes astronomers, alone with their instruments, describe the data as music. They say they can hear the pulse of photons, feel the tempo of the background radiation. In their graphs and curves, they sense a kind of heartbeat, a vibration of time itself. The universe speaks through widening distance, a quiet message that says, I am still unfolding. If you listen now, not with your ears, but with imagination, you might feel that widening in yourself. Each thought, each breath, a small echo of that same expansion. This is the breath of the universe, invisible, inevitable, eternal. It began before there were lungs to breathe it, and it will continue long after the last star goes dark. Let it carry you now, as softly as starlight, through the hush between galaxies, through the calm geometry of forever. For in this breathing cosmos, you are not merely watching the expansion, you are the expansion, a conscious ripple in the universal exhale. The universe keeps expanding, and with each breath, new questions arise. How does space know to stretch this way? Why this speed and not another? Why does the rhythm remain so constant, as if tuned to a melody we cannot yet hear? Astronomers have learned to listen more carefully. They map galaxies by the millions, plotting their positions like notes across a grand sheet of music. When the pattern is played back in data and sound, it reveals a deep harmony. Clusters, filaments, and vast empty voids, each following a hidden beat. The maps show that galaxies are not scattered randomly. They form a cosmic web, a lacework of light surrounding oceans of darkness. Gravity and expansion dance together here, weaving structure into the void. Where matter gathers, gravity pulls inward. Where emptiness dominates, dark energy pushes outward. Between the two, balance emerges, like a tide that never quite comes to shore. This balance defines everything we see. It is the reason galaxies still sparkle in the night instead of collapsing into a single point or fading into infinite thinness. To feel this balance, imagine standing on a quiet beach. The ocean stretches beyond sight. Each wave that reaches you is gentle, but over long time it shapes the world. The universe is that ocean. The waves are its expansion, and dark energy is the invisible moon that draws the tide. Even when you cannot see it, you can feel its pull, steady, soft, unending. There is something meditative about this discovery. For all our instruments and equations, we are still witnessing something simple, space making room for itself. That phrase alone can quiet the mind, space making room for itself. It has no center, no direction, no beginning that can be revisited, and no edge that can be reached. If you traveled forever, you would only circle through new regions of the same infinity, an expansion that carries its own horizon with it, always one step ahead of your gaze. The ancient philosophers once asked whether nothingness could exist. They debated the void. Is it truly empty, or does it hide a kind of fullness? Today we know that emptiness is anything but empty. It is an engine, a source of potential. What we call nothing is charged with quiet energy. Even the most distant patch of space contains the faint afterglow of creation, the hum of photons, and the whisper of virtual particles appearing and vanishing in impossible silence. When we measure that silence, we discover the signature of dark energy itself, a constant background hum that permeates everything. In a sense, dark energy is what prevents the universe from ever settling into stillness. It is the gentle insistence that time should keep unfolding, that distances should continue to widen, that the story should go on. Some scientists describe it as negative pressure in the vacuum, a kind of push woven into the fabric of space-time. Others call it vacuum energy, or the cosmological constant. No matter the name, it behaves like a slow, eternal wind, imperceptible on small scales, but irresistible across the cosmic ocean. This wind touches everything, from clusters of galaxies to the spaces between atoms. And although we cannot feel it directly, its influence defines the shape of forever. Think of light itself, the traveler that crosses this ocean. Every beam we see from distant stars stretches as it moves, its wavelength lengthened by expansion. That stretch is the universe's fingerprint, a soft echo of its breathing. By measuring the light from supernovae, those brilliant dying stars that shine across galaxies, astronomers discovered the truth of acceleration. The more distant the supernova, the faster its home galaxy moves away. This pattern is not random. It is written into the cosmos. The breath is speeding up. Imagine a time far ahead, when galaxies have drifted so far that their light can no longer reach one another. Each island of stars will float in isolation, surrounded by darkness more complete than any night we know. Even then, the expansion will continue, invisible, tireless, calm. It will not stop for emptiness, for silence, or for the end of suns. It will keep breathing. That thought could seem lonely. But there is another way to hear it, not as isolation, but as continuity. The cosmos does not fear distance. It celebrates it. Every new stretch of space is another verse in its quiet song. For all its scale, dark energy is a gentle artist. It does not tear or break. It paints the universe with patience, layer upon layer, until motion itself becomes a kind of stillness. It reminds us that permanence does not come from holding on, but from continuing. To expand is to exist. To drift is to endure. You too expand, not in size but in awareness. Your thoughts stretch toward understanding. Your curiosity reaches beyond what you can see. The same laws that move galaxies move you. In this way, dark energy is not distant. It is the calm pulse inside everything, a shared tempo between cosmos and consciousness. Each time you breathe, you mirror the quiet growth of space. Each pause between breaths is a reflection of the pause between epochs. When you exhale, the universe exhales with you. When you rest, it continues, softly, endlessly, carrying you with it on the tide of expansion. Perhaps that is why the study of cosmology feels so spiritual. It reminds us that we are not separate from the vastness, but woven through it. Every number, every constant, every equation scratched on a blackboard is also a meditation, a way of tracing infinity with the human mind. In the end, the science of dark energy is an act of wonder. It asks us to look at nothing and discover everything. It teaches that even the smallest thought can stretch across eternity. And so, the first great breath continues. Galaxies drift farther apart, stars live and die, space grows and cools, but the rhythm remains, a whisper of motion beneath all things. Tonight, as you listen, you are part of that rhythm. You are floating with the stars, held by the same invisible current. Let it move through you gently. Let it carry you toward quietness. Let the sound of the universe's breath merge with your own, for there is no true separation, only one endless inhale and one eternal exhale, woven together in the silence between worlds. What is nothing? The question sounds simple, almost childish, and yet when science looks closely at the emptiness between stars, the answer dissolves into mystery. Because nothing, in truth, is full of energy, full of motion, full of whispers we can barely detect. Every inch of what we call empty space is alive with invisible activity, a sea of ghostly particles appearing and vanishing, flickering faster than thought. This is not imagination. It is the heartbeat of quantum reality. Even the vacuum hums. When you stare at the dark between galaxies, you are looking into a place that seems perfectly still, a black canvas stretching forever. But if your eyes could see deeper, beyond visible light, beyond X-rays or gamma rays, you would witness a storm of creation and annihilation, an endless dance of subatomic phantoms. They are called virtual particles, not because they are less real, but because they exist only for the briefest of instants. They borrow energy from the vacuum, flaring into being and then returning it before the universe notices the debt. This is the quantum foam, the restless shimmer that fills every void. It is not truly silent, though its sound is too faint for any ear to hear. Some physicists believe this sea of quantum motion is the source of dark energy itself, the energy of nothing, driving everything. To grasp this idea, imagine a calm pond under moonlight. At first glance, the surface seems smooth, but if you look closer, you see it trembling with ripples, small, spontaneous, unpredictable. The vacuum is like that. From a distance, it appears still, but under the surface, tiny fluctuations ripple through existence, and their combined effect may be the invisible pressure that pushes galaxies apart. The idea is astonishing, that the quietest state of reality could also be the most powerful. Einstein once wrestled with this same puzzle. In his equations of general relativity, he found that gravity alone would either cause the universe to collapse inward or expand outward. To make it stable, he added a balancing term, a mathematical pressure that resisted gravity's pull. He called it the cosmological constant. It was, in his mind, a kind of built-in energy of space itself. Later, when Edwin Hubble discovered that the universe was indeed expanding, Einstein removed the term, calling it his greatest blunder. But the universe has a way of humbling even its finest minds. Decades later, when astronomers found that expansion was not just continuing but accelerating, that same constant returned to the forefront. The energy of empty space, the term Einstein once erased, had become the leading explanation for why the cosmos keeps stretching. It was no longer a mistake. it was a clue. If you could assign a number to this energy, you might expect it to be large, given the furious activity of quantum fluctuations. But the measured value is almost impossibly small, so small that it challenges understanding. Theorists once calculated that the total energy of the vacuum should be about 10 to the power of 120 times greater than what we actually observe. That number is so vast that it defies comprehension. It means that, according to quantum theory, space should tear itself apart instantly, and yet it does not. Something cancels almost everything out. This mismatch between what equations predict and what the cosmos reveals is one of the greatest puzzles in all of physics. It is called the cosmological constant problem, or, more poetically, the question of how nothing can be so precisely balanced. This balance is delicate beyond imagining. If the energy of the vacuum were even slightly higher, the universe would have expanded too quickly for galaxies, stars, or life to form. If it were lower, gravity would have pulled everything back together before light had time to travel. Instead, it rests in a perfect middle ground, a whisper of energy, neither too strong nor too weak, allowing complexity to blossom in the silence. It is as though the cosmos knows exactly how much emptiness to hold. To call it empty may be misleading. The vacuum is not an absence, but a presence, a field of pure potential. It has no particles in the usual sense, yet it carries energy, and that energy bends space-time itself. This is one of the strangest truths in modern physics, that the shape of the universe is sculpted not by what is there, but by what is not. Space, far from being a passive backdrop, is an active participant in creation. You can think of it as a fabric that stretches, twists, and flexes depending on how much energy it contains. When that energy is high, the fabric expands more quickly. When it is low, gravity pulls it tighter. And right now, that fabric is gently loosening as though exhaling after a long breath. This interplay between quantum physics and relativity is one of the most profound frontiers of science. Quantum mechanics describes the smallest scales, the jitter of particles, the probabilities that replace certainties. Relativity governs the largest scales, the bending of space and the flow of time. Both are masterpieces of understanding, but they speak different languages. At the meeting point, the vacuum itself, their dialects blur. Quantum fields ripple within space-time, and space-time responds to their presence. The result is an ever-changing sea where nothing and everything coexist. Some believe that to truly understand dark energy, we must one day merge these two great theories into a single harmonious description, a theory of quantum gravity. Such a theory would explain how the smallest fluctuations of the vacuum translate into the grand motion of galaxies. It would show how nothing creates the rhythm of everything. But for now, we are left with awe. It is tempting to think of nothing as lifeless, as cold or static, but perhaps nothingness is the ultimate source of vitality. From the vacuum come particles, forces, waves, and light. From emptiness arise stars, and from stars come worlds, and from worlds, thought. Even consciousness, that quiet spark inside you now, is a ripple in this same sea. The atoms in your body once floated through the interstellar void, bound only by gravity and the slow drift of time. They condensed into stars, burned, scattered, and formed again, born from the same nothing that fills the sky tonight. If you close your eyes and listen not with ears but with awareness, you may sense that nothingness inside yourself, the still background of thought, the pause between breaths. That inner silence mirrors the cosmic silence. Both are full of potential. Both give rise to creation. When you rest in that silence, you are resting in the same mystery that powers the galaxies. You are not apart from it. You are made of it. Perhaps the greatest paradox of all is that the more we study nothing, the more we find. The deeper we look into the void, the more structure appears, waves, fields, probabilities, and forces we are only beginning to name. In the end, the vacuum is not the absence of being. It is the foundation of it. It is the silence beneath every sound, the canvas beneath every painting, the stillness from which all motion flows. And so, when we speak of nothing, we are really speaking of the most profound something imaginable, a quiet energy, a steady hum, a perfect balance between creation and calm. It is the mystery at the heart of the universe, and perhaps the mystery at the heart of you. When you picture the universe, it's easy to imagine space as an empty backdrop, a stage where galaxies and stars perform their luminous play. But what if the stage itself is alive? What if emptiness is not the absence of matter, but the presence of possibility? Everywhere you look, even in the deepest vacuum, there are quantum fields. These fields are not optional ingredients of reality. They are reality. Particles are not separate things floating within them. They are ripples, waves that rise and fall within those invisible seas. So when we speak of nothing, we are speaking of these fields in their lowest, quietest state, a condition we call the zero-point energy. It means that even when every particle is removed and every photon of light extinguished, the fields still shimmer faintly with energy. They never quite go still. That trembling is the foundation of everything. This is why physicists sometimes say, the vacuum is never truly empty. It's a living fabric, a dynamic ocean that underlies all of existence. And here lies the paradox. If we calculate how much energy should arise from these restless quantum fields, the number is enormous, far greater than what we see shaping the cosmos. So something must be canceling almost all of it out, leaving behind just the faintest residue, enough to fuel expansion, but not enough to tear the universe apart. That faint residue may be dark energy itself, a whisper left over from the vacuum's endless hum. It is strange to think that the destiny of every galaxy, every star, every living being depends on this nearly invisible remainder, a rounding error in the arithmetic of the void. The universe could have been anything. It could have rushed outward too fast for structure to form. It could have collapsed before the first atom cooled. Instead, it chose balance. Why? We do not know, but we exist because of it. Some physicists propose that what we call dark energy is not truly constant. It might fluctuate with time, like the slow tide of a hidden field. One idea calls it quintessence, a term borrowed from ancient philosophy, where it meant the fifth element, the substance of the heavens. In this model, dark energy is a slowly changing field that fills the universe and evolves through time, sometimes stronger, sometimes weaker, guiding the rhythm of expansion. If that is true, the cosmos may not expand forever at the same pace. It might slow again one day or accelerate beyond imagining. The breath may yet change. Others suspect that dark energy may emerge from the geometry of space itself. Einstein's equations show that mass and energy can curve space-time, and that curvature dictates how things move. But the reverse might also be true. The shape of space could give rise to energy. In this view, the vacuum's pressure is a property of its curvature, like tension in a stretched fabric. The more it expands, the more that tension shifts, creating a feedback loop that drives acceleration. It's a self-sustaining relationship. The universe expands because of the vacuum, and the vacuum changes because the universe expands. You can imagine it like a breath again. Inhaling and exhaling are not separate acts, but parts of one continuous rhythm. Expansion creates vacuum energy, and vacuum energy fuels expansion. Each feeds the other in silence. At first glance, these are abstract ideas, mathematical dreams painted across infinity. But they carry an astonishing consequence. They suggest that the vacuum, the thing we once dismissed as nothing, is actually the most stable and universal presence in existence. It is everywhere, it cannot be removed, and it may outlast every star, every atom, every trace of light. In the far future, when galaxies have faded into darkness, the vacuum will remain, quiet, infinite, still pulsing with invisible potential. It will be the final survivor of creation. This thought can feel cold, as though eternity were a frozen emptiness, but there is a gentler way to feel it. Imagine this not as loneliness, but as serenity. Not a void, but an ocean so calm that it no longer needs to move. A vast field of pure equilibrium, where every fluctuation is balanced by its opposite. In that balance lies peace, the ultimate rest of the cosmos. And perhaps, within that rest, the seeds of new beginnings are already forming. Because if quantum fluctuations can arise spontaneously in one vacuum, perhaps they can do so again. Maybe new universes can bud from the old, blooming from the quiet fabric of nothing. Cosmologists call this idea eternal inflation, the notion that our universe might be one bubble among many, each emerging from the restless energy of the vacuum. If that's true, then nothing is not only full, it is infinite in creativity. Every possible version of physics, every possible set of stars, every possible life, all could arise from the same eternal hum. To think about this is to feel the limits of comprehension. But that, too, is beautiful. The human mind, so small, so delicate, has reached far enough to ask the same questions that shape galaxies and fields. Our curiosity is itself a form of energy. It expands the world of understanding just as the vacuum expands the universe. You, listening now, are part of that unfolding. Your awareness is a spark born of the same restlessness that makes space stretch and stars ignite. The vacuum hums in you, too. Every atom in your body vibrates with its resonance. Every thought ripples through the same field that governs the cosmos. So when you hear the word nothing, let it no longer mean absence. Let it mean balance. Let it mean potential waiting to be born. For the vacuum is not a void. It is the quiet pulse of existence, the infinite pause between creation and dissolution. It holds the memory of every past universe and the promise of every future one. And tonight, as you drift in that silence, you are listening to the oldest song there is, the song of nothing, which is also the song of everything. There is a moment in cosmic history when everything changes, a silent turning point, billions of years ago when gravity began to lose its hold. The stars didn't notice, the galaxies continued to spin, but something subtle shifted in the balance of power. An invisible force, long buried within the fabric of space, began to rise, softly, patiently, inevitably. It did not roar like fire or collide like matter. It simply pushed, gently, everywhere at once. That quiet pressure was dark energy. And from that moment on, the universe would never be the same. For most of cosmic history, gravity ruled. It gathered clouds of gas into stars, stars into galaxies, and galaxies into clusters. It was the sculptor of everything solid and luminous. Its work was magnificent, a slow dance that transformed chaos into structure. But gravity, for all its strength, has one weakness. It fades with distance. Between nearby stars, it can bind. Across immense voids, it weakens, its pull stretched thin by the growing fabric of space. Dark energy, by contrast, does not fade. It does not depend on mass, nor distance, nor the clustering of galaxies. It is woven evenly through all of space, constant, quiet, uniform. As the universe expands and creates more space, more of that energy appears with it. The total grows even though the density stays the same. It is the only thing in creation that increases simply because there is more where to exist. This is why physicists call it a cosmological constant. In the equations that govern the cosmos, those same equations Einstein first wrote down, dark energy is represented as a steady term. If you were to read it aloud, it would sound something like this. The rate of cosmic expansion squared equals a combination of energy density, curvature, and a constant pressure that comes from the vacuum itself. That constant is the quiet tyrant. It never varies, never weakens, and because it fills every corner of the universe, its effect eventually overwhelms all else. For billions of years after the Big Bang, matter and radiation kept expansion in check. Galaxies formed, gravity condensed structure, and the universe grew but slowed. Then, around 5 billion years ago, something subtle happened. The density of matter had dropped low enough that dark energy became dominant. At first, the change was barely perceptible. Galaxies continued their orbits, stars continued to shine, but on the grandest scales, a new rhythm began to take over. Acceleration. The breath of the universe quickened, not violently, but with infinite patience. To imagine this moment, think of a vast symphony reaching its midpoint. The instruments of gravity had played for eons, deep, slow notes of attraction and collapse. Then softly, another sound began to rise, a higher tone, continuous and unwavering. At first, it blended with the music, then gradually it began to dominate the score. That tone was dark energy. It didn't destroy the earlier melody. It absorbed it. It expanded it into something larger. And the universe, like a song-shifting key, changed its tempo forever. This transition can be traced through light itself. When astronomers measured distant supernovae, those brilliant explosions marking the death of massive stars, they serve as cosmic mileposts. By comparing how bright those explosions appear to how far their light has been stretched by expansion, scientists discovered that distant galaxies were moving away faster than expected. That realization, made in the late 1990s, shook cosmology to its core. It meant that space was not only expanding, it was accelerating. The force behind it could not be seen or touched. It revealed itself only through motion. Even the oldest light in existence, the faint microwave afterglow of the Big Bang, bears this signature. Across that soft radiation, tiny ripples reveal how matter and energy were distributed in the early cosmos. By comparing those ripples to the galaxies we see today, scientists can trace how expansion evolved, and they find the same result again and again. An unseen energy dominates, smoothing the universe, stretching it, quietly dictating its destiny. The cosmic microwave background is astonishingly smooth. Its temperature varies by less than 1 part in 100,000. Such smoothness could not persist if only gravity were at work. It requires a force that counteracts the clustering of matter, a gentle repulsion that keeps the fabric of space from folding in. That repulsion is dark energy. It is easy to think of repulsion as violent, but this one is not. It is the opposite of explosion, an outward pull that feels more like release. It's as if the universe, after straining under gravity's weight, finally exhaled and kept exhaling. It is the great unbinding, not destruction, but letting go. As this expansion continues, its influence becomes more profound. Regions of the cosmos once close enough to share light will drift beyond each other's reach. The observable universe, the portion from which light can still reach us, will grow smaller in relative terms. To future astronomers, galaxies beyond our local cluster will vanish from sight altogether. They will not fade because their stars die, but because their light can no longer catch up with the speed of the expanding space between. In that distant era, the night sky will empty. Only a few neighboring galaxies, bound to ours by gravity, will remain visible. The rest will slip beyond the cosmic horizon like ships sailing over an infinite curve. This fate is not cruel. It is simply the way energy distributes itself. Matter clumps, light travels, and dark energy fills the gaps between both. Its rule is soft but absolute. It governs not by domination but by the persistence of its own nature. It is like the tide, indifferent to the rocks it shapes, yet shaping them all the same. There is something poetic in this inevitability. For all the complexity of the cosmos, black holes, stars, planets, and life, it is an invisible constant that determines how it all ends. Dark energy does not care about form or scale. It does not distinguish between galaxies and atoms. It simply stretches everything that can be stretched. And in that stretching, it writes the universe's long, slow finale. Physicists sometimes describe this shift in dominance as the cosmic transition. When the density of matter fell below the energy of the vacuum, the rules changed. If we could watch that transition as an animation, we would see a graph line of matter density dropping steadily, while the line representing vacuum energy remains flat. At the crossing point, the universe begins to accelerate, as if space itself has remembered its true purpose, to expand. The mathematics behind this change can be expressed simply in words. Imagine an equation where one term represents matter and radiation, and another represents the constant energy of the vacuum. At first, the matter term dominates. Over time, it shrinks as galaxies spread apart. Eventually, the vacuum term, the cosmological constant, becomes the leading player, and acceleration begins. It's a quiet revolution written in geometry. And yet, this tyranny is gentle. Dark energy does not destroy, it dissolves boundaries. It does not push with force, it invites distance. It is the slow triumph of stillness over gravity's embrace, the softest of all powers, ruling not through motion, but through emptiness. If you think of the universe as breathing, then this is the part of the breath where the inhale becomes the exhale, the turning point from compression to release. The rhythm continues, but now it widens forever. When you next look at the night sky, you can sense that widening. Each star you see is part of a grander movement, one that has been unfolding for billions of years. Behind that beauty lies an invisible presence, serene and unstoppable, guiding every light you see farther apart, inch by inch, moment by moment. Dark energy, the gentle tyrant, rules through silence, and the universe obeys, not out of fear, but because it has no other way to be. There is a haunting beauty in equations that describe everything. They are silent, elegant, and mercilessly exact. But when you translate them into words, you discover something deeply human hiding beneath the symbols, a conversation between gravity and emptiness. Einstein once imagined that the curvature of space told matter how to move, and matter told space how to curve. It was a perfect partnership, a dialogue between presence and geometry. But dark energy broke the symmetry. It added a constant whisper, a pressure that told space to keep stretching even when matter had nothing more to say. In mathematical language, the effect of dark energy appears as a single quiet term, a constant value that multiplies the speed of light squared and adds to the curvature of space-time. When spoken aloud, it means, for every region of space, there is a steady pressure that drives expansion proportional to the square of the speed of light and inversely linked to how gravity tries to slow it. In simpler words, space itself contains the instruction to expand. No one inserted that command. It was written into the universe from the beginning, a line of code that never erases. If you could watch the universe over eons, you would see the story unfold slowly, as if played in time-lapse across eternity. In the first billion years, gravity rules, galaxies forming, stars igniting, space glowing with youthful brilliance. In the next 10 billion years, dark energy gathers quiet confidence. It does not rush, it simply waits until matter thins out enough for its influence to rise. Then the scales tip. Gravity becomes the memory of what once held the cosmos together. Dark energy becomes the present and the future. We call this transition cosmic acceleration, but the phrase hides its poetry. It is not motion in the ordinary sense. No object feels the push. Each galaxy drifts calmly, unaware, like a boat carried by a rising tide that stretches the sea beneath it. The distance between galaxies grows, not because they move through space, but because space itself grows between them. This difference matters, for it means there is no center to expansion, no edge, no place to stand still. Everywhere and nowhere is the middle. If you draw a mental picture, imagine tiny dots on a balloon. As the balloon inflates, each dot moves away from the others. Yet none of them are truly traveling across its surface. The surface itself is expanding. Now replace the balloon's skin with three-dimensional space. That is our universe. We are all dots, carried outward by something that has no wind, no direction, and no sound. This is the tyranny of gentleness. It does not conquer through collision, but through inevitability. Even light, the fastest thing in existence, must eventually yield. As the space between galaxies expands faster than light can bridge, photons are stretched until their energy fades away. Their color reddens, their wavelength grows longer and longer, until what began as a bright beam becomes a faint whisper lost to time. To describe this, physicists use the word redshift. It is a simple way of saying that light ages as the universe expands. Each photon is like a traveler on an endless road, its steps stretched farther apart until motion itself becomes memory. This redshifting is more than a curiosity. It is the language by which the universe tells its story. When astronomers look at galaxies billions of light years away, they are reading that story in the color of light. The deeper the redshift, the faster the expansion at the time the light began its journey. By comparing thousands of these cosmic echoes, scientists map how dark energy changed the tempo of the cosmos. The result is unmistakable. Acceleration is real, persistent, and growing. Yet even as we describe it, we do not truly understand it. We can measure its effects with exquisite precision, but the cause remains elusive. Dark energy could be a property of the vacuum itself, the cosmological constant Einstein first inserted, then doubted, then the universe reconfirmed without his consent. Or it could be a dynamic field, a slow-changing essence woven through time, like the ebb and flow of a cosmic tide. Whatever its nature, it commands everything that exists, from the faint glow of the microwave background to the ultimate fate of the stars. Think about that. All that we see, the total mass of every galaxy, every black hole, every atom, every photon, accounts for only a small fraction of reality. The rest, the overwhelming majority, is invisible pressure in the vacuum. This means that the largest portion of the universe is not made of things, but of tendency, a tendency to expand. Existence, at its core, is not a substance, but a direction. If you were to describe this in the quiet language of relativity, you could say, the acceleration of cosmic expansion depends on the difference between the energy density of matter and the constant energy density of the vacuum. When the vacuum dominates, expansion speeds up. No special symbols needed, just the rhythm of balance and imbalance. Gravity pulls inward. Vacuum pressure pushes outward. The result is the universe's long breath of motion. As this continues, galaxies far from one another become forever unreachable. Even if a civilization could travel at the speed of light, it could never bridge the growing gap. The cosmic horizon, the limit beyond which no signal can return, creeps closer with time. In perhaps 100 billion years, almost every galaxy will disappear from view, their light stretched beyond detectability. Future beings, if any exist then, will look up and see only the faint remnants of their own local cluster, the last island of stars in an expanding sea. They may not even know that other galaxies once existed. Cosmology itself could become impossible. This thought can feel lonely, but there is another way to see it. Perhaps this isolation is not loss, but peace, the cosmos reaching equilibrium. As the outward pull of dark energy balances the inward grip of gravity, everything finds stillness in motion. The vast structures we see today, filaments, clusters, and webs of galaxies, are like waves upon an ocean. In time, those waves flatten, and the ocean becomes calm again. The universe, once turbulent, returns to serenity. There's a delicate irony here. Dark energy, the force that will one day dilute every trace of matter, is also what allows beauty to exist now. Without it, the early universe might have collapsed under its own weight before galaxies ever formed. With too much of it, the cosmos would have torn itself apart before stars could ignite. Somehow, the balance was perfect, just enough to allow billions of years of creation before the slow fade began. It is as if the universe tuned itself to both live and let go. The story of dark energy is, in the end, the story of acceptance. The acceptance of impermanence, of motion without destination, of expansion without end. Everything that exists is part of that unfolding, a brief condensation in a sea that never stops widening. Even now, as you listen to these words, you are expanding too. Not in the everyday sense, but in the quantum structure of your atoms, the subtle drift of every particle in your body following the slow rhythm of the cosmos. You are part of the tide. You always were. The gentle tyrant governs not through fear, but through the quiet insistence of existence itself. It has no center, no borders, no anger. It only expands, and that is enough to shape the destiny of everything. If the universe could speak, it would whisper in geometry. Its language is curvature, distance, and the rhythm of expansion. Every equation ever written about it is a translation of that quiet, universal dialect. In this dialect, dark energy is not an invader or an afterthought. It is woven into the grammar of space-time itself. It shapes the way distances grow, the way light bends, and the way time itself flows. Einstein's great field equation once read like a perfect balance. Space and time curve in response to matter and energy. But when he looked at his own mathematics too carefully, he saw something strange. His theory allowed for a universe that could not stay still. He added a counterweight, a steady, gentle term that acted like pressure in reverse. It pushed outward with the same persistence that gravity pulled inward. He called it the cosmological constant. At the time, Einstein believed the universe was eternal and static. He wanted a cosmos in perfect balance, not collapsing, not expanding, just existing. And so he inserted that constant as a quiet correction to preserve equilibrium. Decades later, when Hubble discovered that galaxies were receding, Einstein withdrew the constant, calling it his greatest blunder. He didn't know that this supposed mistake would one day explain the fate of everything. Now, we understand that this constant, that faint pressure of emptiness, is real. It's small, unimaginably small, but over cosmic distances, it becomes the ruling power of the universe. When we describe it today, we might say, the outward acceleration of space is proportional to the cosmological constant multiplied by the square of the speed of light, and inversely related to how matter curves space-time. That single idea, a sentence, not a symbol, captures the destiny of all things. If you picture the cosmic scale, dark energy doesn't behave like a force in the ordinary sense. It does not push galaxies apart like magnets. Instead, it changes the very relationship between points in space. It is as if the ruler itself stretches while the markings upon it remain the same. No matter how far you look, the ratio between expansion and distance remains constant. This ratio is what cosmologists call the Hubble parameter, the quiet heartbeat of the universe. Over time, that heartbeat changes tempo. In the early universe, the rhythm was fast but slowing. Now it is steady but accelerating. If you could write that as a phrase, it would be this: The rate of expansion today equals the original expansion rate multiplied by the square root of the ratio between vacuum energy and total energy. Or in softer words, the universe moves at the pace set by the energy it contains. As dark energy grows in influence, it smooths the wrinkles of creation. The clumps of matter, the filaments of galaxies, the grand webs of structure, all become stretched thin, as though the universe were ironing itself flat. The result is a cosmos that, on the largest scales, looks almost perfectly uniform. The same in every direction, the same in every place. The further expansion continues, the smoother it becomes. It is a kind of cosmic stillness, the asymptotic calm toward which all motion trends. Physicists often classify the universe by its geometry of destiny. There are three great possibilities: open, flat, and closed. A closed universe would one day halt and collapse, a cosmic inhale after the long exhale. An open universe would expand forever, curving outward like a saddle that never ends. And a flat universe rests delicately in between, balanced at the edge of infinite continuation. For decades, no one knew which kind ours was. Then came the measurements of the cosmic microwave background, the faint afterglow of the Big Bang. Its patterns of light revealed the answer. The universe, to an astonishing degree, is flat. Its geometry stretches endlessly in every direction with no detectable curvature. That means expansion will never stop. It will continue, gently but relentlessly, as dark energy reigns unchallenged. The geometry of everything is now ruled by emptiness, a vacuum that carries its own energy density, so small that you could not imagine measuring it, and yet so vast that it defines eternity. If you were to compare it in human terms, the energy contained in every cubic centimeter of space is less than the energy of a candle flame spread across a galaxy. But there are so many cubic centimeters that the total becomes infinite. That is the paradox of scale. What is nearly nothing everywhere becomes everything when multiplied by the universe. This idea, that even nothing has energy, forces us to rethink what existence means. It implies that the vacuum itself is the true foundation of reality. Matter and light are temporary ripples on an ocean that never ceases. When the ripples fade, the ocean remains. That ocean is dark energy. Some cosmologists believe we are living in the second act of the universe. The age of matter is over, and the age of dark energy has begun. This transition has been unfolding quietly for billions of years, and it will continue for as long as there is time. The timeline goes something like this. In the first fraction of a second after the Big Bang, radiation dominated everything. Then matter rose to prominence. Galaxies, stars, and planets forming from gravity's pull. Now, at roughly 13 billion years of age, dark energy leads the dance. Its influence is accelerating, and as time goes on, it will erase all trace of the earlier eras. If you were to express that evolution in words, you might say, at first, energy density decreased with time, then matter density began to dominate. But as expansion continued, the constant energy of the vacuum surpassed all else and set the universe free. Freedom, in this sense, is not liberation from constraint, but the quiet removal of boundaries. Gravity can no longer form new galaxies. Stars born today will one day burn out without replacements. And far into the future, when the last stars fade, dark energy will still be here, unchanged, untouched, patient. This patience feels infinite. It does not measure in years, but in epochs so long that the word time becomes fragile. In 1 trillion years, the night sky will be nearly empty. In 100 trillion, even the faintest red dwarfs will die. And yet, dark energy will continue to stretch space with the same serene rhythm. No faster, no slower, a perfect constant. The universe will not explode or collapse. It will simply drift into a vast stillness so complete that nothing more can happen. This is called the heat death, the final equilibrium of everything. But to think of it as death is to misunderstand it. It is not the end, but the infinite continuation of balance. In that far future, space will still hum faintly with the energy of the vacuum, a soft background pressure like a cosmic heartbeat too slow to hear. Even when matter fades, that hum remains. That hum is dark energy. And perhaps, if consciousness still exists in some form, it will sense that rhythm, the same rhythm you feel now as you breathe in the dark, listening to the silence between stars. Because in a way, the vacuum and your breath are the same. Both are expansions into stillness. Both are continuations of motion without effort. When you breathe, you echo the universe. When the universe expands, it echoes you. Dark energy is the bridge between existence and absence, between something and nothing. It is the faint, eternal reminder that even silence has structure. The gentle tyrant is not cruel. It is the guardian of balance, the silent architect that ensures the cosmos never truly stops. And in that endless continuation, it creates the most profound stillness of all. There is a special kind of silence that only the universe knows. It is not the silence after sound, but the silence after light. The story of dark energy is not only about motion, it is about what happens when motion never ends. If expansion continues forever, what becomes of everything inside it? What becomes of the stars, the galaxies, the light itself? Right now, the night sky looks alive. Billions of suns burn across the darkness, their photons racing through time to reach the eyes of anyone who dares to look up. But this is a brief moment, a snapshot in a much longer film. The universe is already slowing its creation and beginning its long descent into quiet. Galaxies still spin, stars still form. Yet with each passing billion years, the distances between them grow a little wider. Space stretches, gravity weakens, and the web that binds the cosmos begins to thin. Imagine two galaxies, once neighbors in a shared sea of light. Now they drift apart so slowly that even their shared gravity can no longer hold them together. Over time, each cluster becomes its own island, a small continent of stars floating through a black ocean that expands endlessly. We live in such an island, the local group, anchored by the Milky Way and the Andromeda Galaxy. Someday, long after their gentle collision, our merged galaxy will drift alone, while all others fade beyond reach. To any future observer, the night sky will contain only their home galaxy, no sign of the countless others that once filled the heavens. The universe will appear empty again, and yet it won't be empty. It will be full of distance, a calm, infinite, unbroken distance. Dark energy will continue its slow expansion, pushing galaxies apart faster than light can travel between them. This does not mean the galaxies themselves move through space. It means space itself grows between them, stretching like the surface of a rising tide. One day, the light from those distant galaxies will never arrive. The space between will widen faster than the light can cross. To us, it will seem as though the galaxies have disappeared, but they are still there, just forever beyond our horizon. In that far future, even starlight will struggle. Every photon emitted today will stretch, its wavelength growing longer, its color redder, until it fades into invisibility. The energy of light weakens as the universe grows. What began as bright blue becomes deep red, then infrared, then radio waves so long that they dissolve into the background hum of the cosmos. Eventually, the universe will glow only faintly with this ancient radiation, a ghostly afterglow of everything that ever shone. For the stars themselves, the story unfolds more slowly, a tale written in trillions of years. Massive stars burn fast and die young. Smaller stars like our sun live longer, steady and patient. But even patience has limits. Every star, no matter how gentle, will one day exhaust its fuel. The first to go are the giants. They explode in brilliant supernovae, scattering their ashes across space. These ashes form new stars, new planets, new possibilities. But in time, the cycle slows. Gas runs thin. Galaxies lose their reserves. Star formation ceases. One by one, the lights go out. It begins quietly. A galaxy that once glittered with billions of suns now holds only a handful of glowing embers. Red dwarfs, the smallest and most enduring of stars, burn for trillions of years, long after the rest have died. They radiate faintly, a soft crimson glow against a deepening dark. But even they cannot last forever. When their fuel is gone, they fade into black dwarfs, cold remnants that shine no more. The universe, once bright with fire, will cool into shadow. By then, the cosmic microwave background, the faint echo of the Big Bang, will have cooled to near absolute zero. Its temperature will approach a number so small it can barely be imagined, fractions of a fraction of a degree above total stillness. At that point, the last warm places in the universe will be the dying stars themselves, and when even they fade, heat will become memory. But there will still be motion. Even in this distant epoch, gravity will continue its slow, patient work. Dead stars will drift toward one another, forming vast collections of dark remnants, neutron stars, white dwarfs, and black holes. Black holes will dominate for a time. They will consume what remains of nearby matter, merging into titans that sit silently at the centers of empty galaxies. For a while, they will rule the night. But even black holes are not eternal. They too will fade. Through a process called Hawking radiation, they will slowly leak energy back into space. Not violently, but gently, like frost melting in sunlight. A large black hole could take 100 trillion years to vanish. Yet in a universe without end, even that time will pass. One by one, they will dissolve, releasing their last warmth as whispers of energy into the void. When that happens, no stars will remain, no galaxies will glow, no atoms will gather. The universe will reach equilibrium, a condition where everything is so spread out, so evenly balanced, that no further change can occur. This is sometimes called the heat death, but it is not truly death. It is peace, a peace beyond motion, a peace beyond light, a peace that was written in the very equation of expansion from the beginning. You might wonder, is this truly the end? Is there nothing beyond the dark horizon? Perhaps not an end, but a transformation. Because even the vacuum hums faintly with energy, and energy, given enough time, can create again. Maybe new universes bloom from the quiet fields of the old. Maybe the story continues in ways we cannot yet imagine. What we call the end might simply be the slow turning of the page. For now, though, we exist in the brightest chapter. The stars still burn, galaxies still shimmer, and the cosmos still sings softly in microwaves and starlight. We are witnesses to the middle of the story, a story that began with fire and will end with calm. Dark energy writes its final sentence not with destruction, but with stillness. The fate of the stars is the fate of all things, to fade gracefully into balance, and that balance is the universe's most perfect form of peace. If you could fast forward through the ages, skimming across trillions of years as though time were water, you would watch the universe dim. The great clusters would drift apart, each one swallowed by the horizon of its own isolation. The quiet between galaxies would widen, and the rhythm of creation would slow until even the birth of a single star became rare. What began as fire will end as faint warmth, a long exhale of energy returning to the dark. Entropy, that simple, patient law, is the thread running through it all. It tells us that energy spreads, that order gives way to stillness, that heat flows from the bright to the cold. In human words, entropy means everything, given time, finds equilibrium. A hot cup of tea left alone cools to the room around it. So too does the universe cool to the emptiness around it. Every exchange of heat, every flicker of light, every fusion within a star is a step toward that equilibrium. And equilibrium, on a cosmic scale, is silence. The journey there will be slow, so slow that the word forever feels almost inadequate. First, galaxies like ours will remain as glowing islands, each surrounded by billions of light years of darkness. Then, within those islands, the stars will fade one by one. The heavyweights will vanish first, then the long-lived dwarfs. Planets will freeze, moons will wander from their orbits, and space will become a cathedral of quiet stone. Even the dust will cool, its faint infrared shimmer thinning into nothing. After the last star flickers out, black holes and dark remnants will remain, the bones of creation. For a time, these black holes will feed on the sparse remains of matter drifting near them. But when nothing is left to consume, they too will begin to fade. Hawking radiation, that faint ghostly glow, predicted by the marriage of quantum physics and gravity, will slowly carry their energy away. It is a beautiful irony. The darkest things in existence will end their lives by shining, ever so faintly, into the void. Over unimaginable spans they will evaporate completely, leaving behind only a soft bath of photons, the last whispers of heat in an endless night. When that era arrives, the cosmos will be vast and cold, filled only with particles drifting apart, so far between that they will never meet again. Time itself will lose meaning, for change requires contrast, and there will be none left to mark its passage. The clock of the universe will not stop. It will simply slow until each second stretches beyond comprehension. To describe it in words rather than mathematics, the arrow of time will continue pointing forward, but it will move through a landscape where nothing new can ever happen. And yet, even in this imagined stillness, there remains a quiet wonder. The universe will not vanish. It will simply rest. Every atom that ever existed will still hum faintly with energy, though scattered across distances so immense that they might as well be separate worlds. Each particle will travel alone, a solitary traveler in an infinite ocean, never touching, never slowing, carrying within it the echo of creation. If one could stand somewhere in that distant epoch, though there would be no place to stand, no ground, no light, no up or down, and listen carefully, you would hear nothing. But beneath that nothing would lie a deep, tranquil balance. It would be the sound of the cosmos asleep. Some physicists call this end the Big Freeze. The name fits, though it is less an event than a mood. There will be no explosion, no collapse, no sudden transformation. Only the gradual fading of warmth, the quiet spreading of energy until everything is perfectly even. In that state, the cosmos will be everywhere the same. A smooth sea of low-temperature light, unchanging, unending. The story that began in fire will end not in tragedy, but in stillness. It is difficult for human minds to imagine such stillness. We live in motion, heartbeat, breath, day and night, birth and decay. But the universe teaches us that motion and stillness are not enemies. They are phases of the same rhythm. Just as breath alternates between inhale and exhale, so too does creation alternate between growth and rest. Perhaps what we call the end is only the exhale, a pause before some new kind of breath begins. The idea of new beginnings emerging from stillness has its roots in physics as well as philosophy. Quantum fields, even in their lowest state, still fluctuate. These tiny tremors of energy could, in principle, spark new universes into being, each with its own laws, its own story, its own version of time. If this is true, then the death of one universe is merely the seed of another. The multiverse, a vast collection of universes blooming endlessly, could be the ultimate expression of entropy's creativity. Instead of ending in silence, reality may hum forever with the birth of new worlds rising from the calm of the old. But such thoughts are not certainties, they are dreams, the cosmic dreams of minds that still look up at the stars and wonder, and that wonder itself is part of the story. Even if the cosmos will one day fade, our curiosity, this need to understand, is proof that the universe, for a moment, became aware of itself. It built eyes to see, minds to ask, voices to whisper its own questions back to the dark. You listening now are one of those voices. When you breathe, you echo the earliest rhythm of the cosmos. When you sleep, you rehearse the stillness that lies ahead. And when you wonder, you continue the oldest conversation, the one between matter and mystery, between being and becoming. Dark energy may guide the universe to stillness, but curiosity gives that stillness meaning. Perhaps the truest fate of the stars is not their fading, but their transformation, from burning light to thinking light. And so the story continues, quietly, beyond the reach of galaxies, beyond even the measure of time. The universe rests, but it does not die. It dreams. And somewhere in the calm between one heartbeat of creation and the next, another light begins to rise. There is a point in every great mystery where observation ends and imagination begins. Dark energy sits at that boundary, half understood, half dreamed. We have measured its fingerprints in the way galaxies drift apart, in the faint red shift of distant light, in the echo of the cosmic microwave background. We know it exists, yet we do not know what it is. It does not glow, it does not clump. It passes through matter, unseen, untouched. It is everywhere, and yet it is not a thing in the way air or light are things. It may be woven into the very geometry of space itself. Scientists have tried to name it, to fold it neatly into equations, but each name feels like a shadow of something larger. The first name came from Albert Einstein, a quiet addition to his theory of general relativity. When he first described how gravity bends the fabric of space and time, he realized that, left alone, the universe should collapse under its own weight. So he introduced a kind of balancing term, a gentle outward pressure that would keep the cosmos static and eternal. He called it the cosmological constant. In his equations, it appeared as a small term that counteracted gravity's pull. In simple words, it meant that even empty space had an energy of its own, a quiet push that resisted collapse. Later, when astronomers discovered that the universe was expanding, Einstein removed that term, calling it his greatest blunder. And yet, decades later, the universe revealed something unexpected. Its expansion was not slowing down, it was speeding up. That forgotten constant suddenly looked less like a mistake and more like prophecy. Today, many cosmologists still use Einstein's idea, the notion that space itself has energy, to describe dark energy. In this view, as the universe expands, new space appears, and each new patch of space carries the same small amount of energy. The result is subtle but profound. Even as the universe grows larger, its energy density remains roughly constant, so the total energy actually increases over time. That gentle, persistent energy acts as a quiet repulsive force, causing the expansion to accelerate. No explosions, no winds of force, just the natural stretching of the cosmic fabric as energy seeps softly into every new thread of existence. But this explanation, elegant as it is, raises deeper questions. Where does this vacuum energy come from? Why is it so small, and yet powerful enough to shape the fate of the universe? When scientists use quantum theory to estimate the energy of empty space, the numbers are staggering. Quantum physics suggests that even a tiny region of space should be filled with vibrating fields, fields of light, matter, and all known forces, each contributing to the total energy of the vacuum. When these contributions are added together, the predicted energy is enormous, so large that it would tear the universe apart instantly. And yet, the real universe is calm, stable, and expanding gently. The difference between theory and reality is so vast that it has been called the worst prediction in the history of physics. The calculated value of the vacuum energy is roughly 1, followed by 120 zeros, times larger than what we observe. Imagine predicting a mountain and finding a pebble instead. That gap between the theoretical mountain and the observed pebble is one of the great unsolved puzzles of science. Some think the equations themselves may be incomplete, that we are missing a piece of the cosmic language that ties quantum mechanics to gravity. Others suspect that dark energy is not a constant at all, but something dynamic, something that changes slowly over time, like a tide moving through the sea of space. This idea is known as quintessence. The word comes from the ancient Greeks, who believed the universe was made of 4 elements: earth, water, air, and fire, and a 5th, unseen element they called the quintessence, the essence of the heavens. In modern cosmology, quintessence describes a hypothetical field, similar to the fields in quantum physics, that fills all of space and exerts pressure outward. Unlike Einstein's constant, quintessence can evolve. Its strength can rise or fall with time, and its behavior might change as the universe expands. If true, dark energy would not be a fixed property of space, but a living, breathing field, a kind of cosmic weather that shifts slowly over billions of years. There are many variations of this idea. Some describe quintessence as gentle and smooth, others imagine it fluctuating like waves. A few theories even suggest that dark energy could one day reverse direction, changing from repulsive to attractive, causing the universe to slow down again or even collapse in a distant Big Crunch. These are not predictions, but possibilities, theoretical lullabies sung by physics itself. For now, observations show no sign of such reversal. The expansion continues, steady and serene, but the fact that we can imagine it shows how deeply we long to understand the invisible hand guiding the cosmos. Other scientists look elsewhere for answers. Instead of adding a new ingredient to the universe, they ask whether our understanding of gravity might simply be incomplete. Perhaps dark energy is not a substance at all, but a symptom, a sign that the equations describing gravity need to be rewritten. In Einstein's theory, gravity is the curvature of space-time itself. Mass and energy tell space how to bend, and that curvature tells matter how to move. But what if, on the largest scales, this relationship changes? Maybe gravity behaves differently when stretched across the cosmic web. Maybe the fabric of space has properties we have yet to measure. These ideas fall under the term modified gravity. They are like quiet whispers in the dark, reminding us that even our most cherished theories may one day need to evolve. Each of these possibilities, Einstein's constant, quintessence, modified gravity, paints a different portrait of the same unseen artist. And yet, none of them feels complete. Each answers one question and opens 10 more. But that, perhaps, is what makes the search for dark energy so profoundly human. We do not simply want to measure, we want to understand, to find the pattern in the silence, to trace the invisible hand that keeps the stars apart. In the end, dark energy may be less a puzzle to be solved and more a mirror for our own curiosity. It reminds us that knowledge is not static. It expands, just like the universe it seeks to describe. Every question answered stretches the horizon of wonder a little farther. And beyond that horizon, still unseen, still waiting, is the next mystery. Every great mystery, no matter how complex, eventually turns into a mirror. When we look at dark energy, we see not only the universe's secrets, but our own reflection, our need to understand, to give names to silence. Over the years, scientists have built many mirrors for this mystery. Some shine with equations, others with imagination. Each reflects a different piece of truth, a different way of thinking about the invisible, and perhaps none are final. After Einstein's constant and the theories of quintessence, some physicists began to think that dark energy might be telling us something profound about the structure of reality itself. They wondered whether space is not a smooth, continuous fabric, but something deeper, something that holds information the way a page holds words. If that sounds abstract, it is. But it is also one of the most poetic ideas in modern physics, the idea that the universe may be holographic. In a hologram, a three-dimensional image is stored in two dimensions. Every part of the surface contains information about the whole. If you break a hologram into pieces, each piece still holds the image. Fainter, yes, but complete in essence. Some physicists believe the universe works the same way. They propose that the three-dimensional world we experience might emerge from a kind of cosmic code written on the distant boundary of space. In that view, everything we see, every galaxy, every atom, every breath, could be the unfolding of information stored at the edges of the cosmos. It is as though the universe itself were a grand projection, not illusion, but expression. And if this is true, dark energy may not be a force at all, but a natural feature of that deeper information, a result of the way the holographic code unfolds and evolves. Space expands because the information that defines it is changing, increasing, unfolding like a dream being written in real time. It's a theory both scientific and poetic. It does not diminish reality, it deepens it. For if the universe is a hologram, then every part of it, even you, listening to this now, contains the pattern of the whole. Your atoms are not separate from the galaxies. Your consciousness, arising from stardust, is part of the same informational field that carries the hum of creation. Other theories explore the same mystery from different angles. Some physicists suggest that what we call dark energy might not be a property of space at all, but the result of our perspective, a kind of illusion created by how we measure time and distance in a universe that may have more dimensions than we can see. In certain models of string theory, the universe may have additional dimensions curled up so tightly that they are invisible to us. Dark energy, in that view, could be a shadow of those hidden dimensions, a gentle echo from beyond our three-dimensional perception. We would not feel it directly, but we would see its influence, the subtle stretching of the cosmos, the quiet drift of galaxies apart. And then there is the multiverse, not the cinematic kind, but the mathematical one, born from the same equations that describe cosmic inflation, the rapid expansion that followed the Big Bang. In those equations, inflation need not stop everywhere at once. Some regions may slow and form universes like ours, while others continue expanding, bubbling outward, creating an infinite sea of universes, each with its own laws of physics, its own version of dark energy. In some, expansion may accelerate faster. In others, it may never have begun. Each universe becomes a kind of cosmic bubble, floating in an endless froth of possibility. And within one such bubble, ours, the value of dark energy happens to be just gentle enough to allow galaxies, stars, and life. If it were stronger, the universe would have expanded too quickly for matter to ever form. If it were weaker, it might have collapsed long ago. It is as though our universe were balanced on a narrow ridge between chaos and emptiness, a precarious harmony that allows us to exist. Some call this coincidence, others call it fine-tuning. But perhaps it is simply the natural result of countless universes exploring every possible combination of laws. In such a cosmic landscape, we find ourselves in the one that allows observers to ask why. It is humbling, this realization that we might live in just one chapter of an infinite library of worlds. And yet it is strangely comforting too, because even if there are endless variations, each one would still be a verse in the same universal poem. Every universe would hum with the same quiet rhythm, energy expanding, space stretching, time flowing like breath. In this way, dark energy becomes not an error to be corrected, but a rhythm to be heard, a gentle tempo in the symphony of existence. And perhaps that is the truest lesson. For every theory, the cosmological constant, quintessence, modified gravity, the holographic principle, the multiverse, is not an ending, but a verse in that ongoing symphony. Each offers a new language for the same unspeakable wonder. Each brings us closer, not to finality, but to awe. Because the more we learn, the more we realize that knowledge and mystery are not opposites. They are partners in the same cosmic dance. The search for dark energy is a search for our own reflection in the infinite. We look outward and find ourselves looking inward. We ask what drives the galaxies apart, and in doing so, we rediscover our own curiosity. The quiet pressure that drives thought forward, just as dark energy drives the stars apart. The universe expands because curiosity expands, because possibility is woven into the fabric of being. We reach for understanding not to conquer the unknown, but to join it, to be part of the breath of the cosmos itself. So let the mystery remain open. Let it be what it has always been, a horizon to move toward, not to reach. For even if one day we discover the true nature of dark energy, there will still be something beyond it. Another question, another horizon, another dawn. And perhaps that is the quiet promise of the universe, that wonder never ends. If the universe could sing, its song would have no lyrics, only motion. It would not be a melody of notes, but a harmony of distances. Each galaxy a soft tone, each cluster a chord, and together they form a symphony of expansion, playing on a scale of billions of years. In this music, dark energy is not the conductor shouting orders. It is the rhythm itself, a steady, almost imperceptible tempo guiding everything outward. From the birth of the first light to the deep silence of the last star, that rhythm never falters. It is the slowest heartbeat imaginable, the cosmic pulse that defines time itself. When astronomers measure how galaxies move away from us, they are not just counting distances, they are listening. The light they see is a record of ancient chords, each redshift a deepening tone, each wavelength stretched like a string played softer with age. In the early universe, the tempo was fast and chaotic, like a young heart racing. Matter collided, stars ignited, galaxies spun in newborn confusion. But as dark energy grew dominant, the rhythm slowed, calmed, and began to breathe. Now the universe expands like a slow exhale, a sigh that never ends. Imagine standing at the edge of a cosmic sea and watching galaxies drift like lanterns on the tide. You would feel no wind, no sound, no vibration. Yet the motion itself, the stretching of space, would carry its own kind of harmony. Not a vibration of air, but of geometry. A symphony written into the structure of existence. The tempo of expansion today is measured by what astronomers call the Hubble constant, a way of saying how quickly galaxies recede for every million parsecs of distance. But in simpler terms, it means this: the farther away something is, the faster it moves. Like ripples spreading in water, each circle expands a little more quickly than the last. It is not an explosion into space, but an expansion of space, a stretching of the fabric itself, everywhere and all at once. If you could somehow slow time and compress the universe's history into a single song, it would begin with silence. Then a burst of brightness, the cosmic overture. As matter cooled, the notes deepened. Atoms formed, stars were born, and gravity began weaving harmonies of light and shadow. Each merger of galaxies added percussion. Each supernova became a cymbal crash. But through it all, dark energy's rhythm remained, steady, calm, patient. It was not loud enough to notice at first, but over time it took the lead. Now in the present epoch, its melody is unmistakable, a low, continuous hum that fills the entire cosmos. This hum is everywhere. We can't hear it, but it surrounds us. It lives in the faint radiation of the cosmic microwave background, in the slow drift of distant galaxies, in the geometry of time itself. If we could translate that rhythm into sound, it would be far too deep for human ears. Its frequency would be measured not in hertz, but in centuries. A single beat might last 1 billion years, and yet to the universe that is perfectly natural, a tranquil tempo for an eternal dance. The physics of this rhythm is simple in concept, even if vast in scale. Gravity pulls inward, dark energy pushes outward. The balance between them sets the pace of expansion. In the early universe, matter and radiation dominated, and gravity kept the tempo quick and dense. But as the universe grew, matter thinned out, while the influence of dark energy remained constant, always there, like a faint background tone. Eventually, the two forces traded places. Dark energy took the lead, and the music changed key. The tempo became smoother, the harmonies more open, as galaxies drifted further apart. We live in that softer movement now, a movement defined not by chaos, but by calm. In some ways, you can think of the cosmos as a single living symphony. Stars are its instruments, space its stage, and time its sheet music. Each star burns for a while, plays its note, then fades. But the song continues. Even silence in this great score is part of the melody. The pauses between stars are as meaningful as the stars themselves. And dark energy, that invisible tempo, is the reason the song does not end in collapse. Without it, gravity would have drawn everything inward, rewinding the melody into dissonance. But with it, the universe continues outward, each verse softer than the last, each measure longer and more serene. It is tempting to ask, why does the universe play this particular rhythm? Why this tempo and not another? Why a constant expansion rate that balances so delicately between too fast and too slow? Physicists search for answers, but perhaps the question itself is more poetic than physical. Perhaps the universe's rhythm is what allows consciousness, what gives time its texture, and life its fleeting beauty. If the expansion were much faster, galaxies would never have formed. If it were slower, everything would have collapsed long ago. Between those extremes lies the perfect tempo for awareness, for the brief bloom of stars, for chemistry and color, for thought itself. We are, in a sense, born of rhythm. We live in its gentle measure, and we fade with its final notes. If you close your eyes and imagine the sound of the universe, you may not hear anything, but you might feel it. The faint pulse beneath reality, the quiet tension that holds galaxies apart. It is not something to fear, it is balance. It is the natural breath of being. Dark energy is not chaos, it is structure. It is the silence that keeps the melody pure. Every moment in the universe is part of a larger composition. Each instant follows the one before it with quiet precision, just as each note in a melody depends on the one that came before. Time is not only something we measure, it is something we hear, in the rhythm of motion, the pacing of change. Dark energy does not break that rhythm. It keeps it steady. When you look at the night sky, you are seeing the past arranged like a musical score. Light from nearby stars is recent, a gentle piano note still echoing. Light from distant galaxies is ancient, a deep, low chord fading into the distance. Together, these layers of light form harmony across time. Astronomers, in their own way, are composers. They listen to this harmony through instruments that collect starlight and translate it into patterns, not of sound but of wavelength and motion. Each galaxy has its tone. The farther it drifts, the redder its color becomes. That reddening is the stretching of light itself, the same way a violin string sounds lower when loosened. So the universe's expansion literally lowers the pitch of its own light. It is the slowest, deepest bass note imaginable, a song whose beat lasts billions of years. In this symphony of distance, dark energy acts as the metronome. Its tempo is subtle but unwavering. It determines how quickly space grows and how gently time unfolds. If the tempo were faster, everything would disperse before harmony could form. If it were slower, gravity's pull would overpower the rhythm, compressing the melody back into silence. But somehow it balances perfectly, a tempo that allows both structure and motion, creation and rest. The universe plays in a kind of steady time, where expansion and gravity take turns keeping the beat. They are partners, each shaping the other, each ensuring that the song continues. Somewhere between those beats lies the reason we can exist at all. Because expansion sets not only distance, it sets time. The faster the universe expands, the more gently time flows. Moments stretch like the spaces between notes, allowing complexity to form. A slower expansion would have crushed matter too soon. A faster one would have left atoms scattered and alone. Dark energy, by maintaining this delicate tempo, gives the cosmos room to think, to evolve, to dream. It gives rise to rhythm at every scale, the spin of planets, the orbit of moons, the flicker of neurons, the inhale and exhale of breath. Each rhythm is a smaller echo of the cosmic one. If you close your eyes, you can imagine that rhythm as a sound, a deep, low hum beneath reality. It is not made of air or vibration, but of space itself stretching. This hum does not begin or end, it continues through every age. Even after the last stars fade, that background tempo will remain, a pulse in the geometry of existence. It is the ultimate drone, the infinite note. Scientists describe this tempo using a simple phrase: the rate of expansion increases over time. In words instead of numbers, this means that every billion years, the universe's outward motion becomes a little faster. Not dramatically, not explosively, just steadily. The distance between two distant galaxies that might have increased by 1 light-year long ago now increases by slightly more. That difference is the rhythm accelerating. Not because something is pushing harder, but because space itself continues to create more space. It is a self-propelling harmony, a melody that writes itself. There is beauty in this simplicity. It suggests that the universe's song requires no conductor, no external hand. The rules of physics themselves are the sheet music. Gravity plays the low tones, dark energy sustains the high ones. Matter forms the melodies, brief, bright, and intricate, while entropy provides the reverb, softening everything with time. And when you step back far enough, the entire composition sounds like balance, a cosmic equilibrium between tension and release, motion and rest, sound and silence. Our human music, in its own small way, reflects this. When you listen to a lullaby or a requiem, you are feeling the same principles that guide galaxies, a rise and fall, a note held just long enough to make you anticipate the next, a pattern that creates comfort through repetition. This is not coincidence, it is resonance. We are made of the same atoms that follow the same laws. The reason harmony pleases the ear is the same reason orbits form, stability within motion. A universe that knows how to expand smoothly is the same universe that knows how to sing softly. Even silence fits perfectly into this design. A rest in music gives meaning to the next note. A pause in creation gives meaning to the next burst of light. Dark energy ensures there is space for those pauses, literal space. Without expansion, everything would be noise, too dense, too hot, too fast. But the steady growth of the cosmos creates room for patterns to form. That room is where beauty lives. The pause between atoms, the gap between stars, the quiet between thoughts, all are made possible by the same underlying rhythm. If someday intelligent life elsewhere listens to the cosmos, they too will recognize this harmony. Not because they share our biology, but because they share the same physics. A being made of plasma, or of gas, or of something we cannot imagine, would still live according to the same tempo, their world orbiting, their atoms vibrating, their time unfolding in measure. They would feel the same rhythm, even if they called it by another name. And perhaps, somewhere far away, they too write lullabies about the slow expansion of everything they know. The music of the universe, then, is not something played for us. It is something played through us. Every cell, every heartbeat, every thought is a chord in that grand composition. When we love, when we rest, when we dream, we are not stepping outside of physics. We are harmonizing with it. Dark energy hums beneath every motion, keeping time for existence itself. We are part of its melody, brief but essential, like a single note in an endless song. And when this song finally drifts toward silence, when galaxies are far beyond sight and time slows to a hush, that silence will not be emptiness. It will be the final chord of balance, resonating forever. The universe will not stop, it will hold, like a note sustained beyond hearing, fading but never gone. There comes a point in every song when the melody grows faint, when the instruments drift apart, and what remains is not silence, but the gentle echo of everything that came before. The universe will reach that point too, not suddenly, not violently, but gracefully. As expansion continues, galaxies will drift so far apart that their light will never meet again. The night sky, once alive with stars, will grow darker, quieter. But darkness, in this case, is not an ending. It is a rest, a pause between movements in an endless symphony. Entropy, the slow spreading of energy, is the universe's way of softening sound. It is how the cosmic music unwinds. Every supernova, every burst of light eventually dissolves into heat. That heat drifts outward, thinner and thinner, until it merges with the general hum of the cosmos. It's like the final vibration of a gong fading into still air. You can't say exactly when it ends, because its echo lives on in the quiet. The same is true of existence itself. No moment ever truly disappears. Each vibration, each photon, each breath of energy adds to the cumulative rhythm of everything. The music does not stop, it merely stretches, like a note sustained across eternity. Scientists call this far future stillness the heat death of the universe. But perhaps that name is misleading. Death implies absence, a kind of nothingness. Yet the heat death is not a vanishing, it is a perfect equilibrium. Everything that can move has moved, everything that can shine has shone, everything that can resonate has resonated. What remains is not despair but balance, a single all-encompassing tone, even and eternal. Dark energy continues its quiet tempo through all of this. It never stops expanding space, never pauses the rhythm. But the rhythm slows into a near-silent breath, a calm so deep it could be mistaken for sleep. In this distant epoch, time itself will lose much of its meaning. We measure time by change, by the ticking of a clock, the beating of a heart, the flicker of a star. But when change becomes rare, when there are no more stars to mark the hours, time becomes almost indistinguishable from stillness. And yet the universe will still be, still expanding, still holding its soft, invisible pulse. That pulse is the essence of dark energy, not a force that demands, but one that endures. In a way, we might say that dark energy teaches patience. It reminds us that even the most powerful transformations can occur without sound or violence. Every billion years, the universe grows a little larger, a little quieter, a little more refined in its balance. The expansion does not rush, it simply continues, steady, serene, infinite. The same rhythm exists within us. Our own lives are smaller reflections of that cosmic breath. We inhale and exhale, we expand and contract, we rise and rest. The pulse of dark energy echoes in every heartbeat, not as a literal vibration, but as a metaphor for existence that never stops evolving. When we look back at the earliest light, the faint microwave glow left from the beginning, we are hearing the first notes of this song. That glow has stretched across the sky for billions of years. Its pitch lowered, its color cooled, but its presence unbroken. It whispers across all directions, a quiet reminder of how the music began. That ancient light is the memory of the universe itself. It carries information, a record of temperature, of density, of rhythm. Even now, dark energy moves through that same space, gently increasing the distance between every echo. The cosmic background becomes more diffuse, like sound dissipating in an endless hall. But the hall never closes, it only grows larger. If a future civilization were to exist in that far-off age, a billion years from now, they might find themselves in a lonely galaxy with no visible neighbors in the sky. They would see only darkness beyond their stars. They might build observatories, listen carefully for the faintest background hum, and wonder if they were truly alone. They might suspect that their galaxy was the entire universe. Only through deep, quiet listening could they perhaps detect the residual tone, the barely perceptible vibration of expansion. And perhaps, through that discovery, they would feel awe rather than isolation. They would know that the silence around them was not emptiness, but continuation. Even now, as we live in a bright and noisy universe, we can hear faint traces of that cosmic rhythm. Not through our ears, but through our measurements, through telescopes, through detectors that translate starlight into data, and data into understanding. The more precisely we measure, the more elegant the music appears. It's not random, it's patterned. It's structured in a way that invites reflection. Every discovery adds another layer to the composition, another instrument joining the quiet ensemble. And when scientists talk about cosmology, they are not merely listing numbers and theories. They are describing the score of reality, the very architecture of the universe's song. Consider this. If the cosmos were truly chaotic, if dark energy were uncontrolled or uneven, the result would not be music but noise. Galaxies would tear apart violently, the tempo would be unpredictable. But it isn't. The data show astonishing precision. Expansion follows a near-perfect rhythm, like a metronome that has been ticking for billions of years. That stability is part of what allows existence to flourish. It's the universal equivalent of a heartbeat that never falters. So when you breathe, you are in a sense sinking to that same steady beat. You expand and contract, just as the universe does on a grander scale. All of this leads to a final reflection, that maybe the purpose of dark energy is not mechanical at all. Maybe it is aesthetic. Maybe the universe expands because beauty requires space, because harmony needs distance so that every note can be heard clearly, because creation itself is the act of separation, of giving each thing room to exist, to shine, to sing. Dark energy provides that room. It ensures that no part of existence becomes too crowded to express itself. It lets galaxies dance without colliding, lets light travel freely, lets time itself unfold with grace. And so, when all is said and done, the universe may not end in darkness, but in music too slow to hear, a vibration so stretched across time that it feels like silence. That silence, however, is not nothingness. It is the purest resonance imaginable, existence itself humming forever. The final chord never fades, it just becomes the background tone of being, and in that stillness, everything, past, present, and future, is in perfect tune. And so we return to silence, the same silence that began everything, the same quiet pulse that never truly ends. Dark energy hums softly beneath all creation, an invisible heartbeat expanding the cosmos outward, moment by moment, breath by breath. You've drifted with galaxies now, felt the slow waltz of their retreat, the patient rhythm of time unfolding like a sheet of light. You've seen that nothingness is not absence, but a stage vast enough for all existence to play upon. You've learned that space is alive, not with noise or fire, but with balance, with order, with quiet motion. In the earliest moments after the beginning, everything was light and heat. Energy was dense, impatient, and wild. The universe's first song played too fast to hear. But over billions of years, the tempo slowed. Like a long exhale, space stretched. Galaxies found their distance, stars learned their rhythms, and planets began to spin quietly within their orbits. Somewhere on one of those planets, a small voice began to wonder why. That voice became us. And so tonight, you are not simply listening to the story of the universe. You are part of its unfolding breath, a thought within the great pause between movements. We sometimes think of expansion as loneliness, galaxies drifting apart, stars cooling into isolation. But perhaps it is not separation. Perhaps it is permission. Every part of the cosmos is given room to exist, to create, to evolve. Distance is not emptiness. It is grace. Without it, no melody could form. No star could shine without room to release its light. No consciousness could arise without quiet space around it. Dark energy ensures that quiet. It is the universe's way of saying, grow, there is room for you. When you breathe, you mirror that same generosity. Each inhale expands your inner universe. Each exhale releases energy back into the whole. Your lungs, your cells, the very atoms within you, they move to the same rhythm that guides galaxies. It is not poetry. It is physics. Atoms are mostly space. Your body is a constellation of emptiness woven together by invisible forces. You are, in a literal sense, made of the same quiet fabric as the expanding universe. And so when you feel small beneath the stars, remember, you are not beneath them. You are made of them. You are the cosmos, learning to perceive itself. The night sky is not something outside of you. It is a mirror. Each photon that reaches your eyes has traveled across light years of time to tell you one simple truth. Existence remembers itself. Light never forgets its journey. It carries its history within its wavelength, its stretching, its fading. And when you see a distant galaxy, you are not seeing where it is. You are seeing where it was. A note played long ago, still echoing through the symphony of space. If dark energy could speak, perhaps it would not use words at all. It would speak in patience, in the slow unfolding of time, in the quiet persistence of expansion. It would tell us that growth does not require noise, that progress can happen invisibly, that movement can exist without haste. And maybe that is the lesson hidden within the universe's design, that even infinite acceleration can be tranquil. There will come an age when all the stars are gone, when even black holes have evaporated into faint radiation, when galaxies no longer share light between them. And yet even then, the universe will not end. It will simply continue expanding, calmly, endlessly, like a thought that refuses to fade. That future is not sad, it is peaceful, because every particle, every wave, every whisper of energy will still be in motion, still part of the same eternal rhythm. The music will not stop, it will slow into perfection. The silence that remains will not be empty but full, so full it needs no sound. We spend our short lives trying to understand this vastness, building equations, writing theories, seeking meaning among the stars. But maybe the universe does not need to be solved. Maybe it simply needs to be listened to. Because when we stop trying to capture it in formulas, when we simply breathe with it, we find that understanding appears on its own, not in words, but in feeling, in awe. The same awe that the first humans felt when they looked up at the night sky and realized that the lights above them were not holes in the ceiling of heaven, but suns, infinite and far, shining through the veil of time. If you listen carefully, you can feel the same awe now. It hums in the silence between your breaths. It vibrates faintly in your chest, the echo of billions of years of motion. That hum is not just inside you. It is the universe reminding you of your place within its song. You are not separate from the cosmos. You are its awareness, its curiosity, its voice. And just as every galaxy expands outward, so too does your consciousness, ever reaching, ever wondering. Dark energy, that invisible tide, has no preference, no direction, no purpose we can define, and yet somehow its presence allows everything else to exist. It is the silent permission for stars to form, for atoms to bond, for life to breathe. Without it, gravity would have pulled all things back into collapse. But because of it, the universe has a future, open, vast, and infinite. So perhaps dark energy is not a tyrant after all. It is an artist, a composer of stillness and distance. It writes not in words, but in expansion, not in color, but in time. The next time you look at the stars, imagine that each one is part of a greater pattern, a chord struck once, still resonating across eternity. Your life, your heartbeat, your quiet thoughts in this moment, they are harmonics of that same vibration. Even after your voice fades, its echo will ripple softly through the cosmos, woven into the ever-growing fabric of space. No action, no moment, no breath is wasted. Everything contributes to the ongoing song. And maybe, in that far future, when only the whisper of expansion remains, some remnant of what once was will still shimmer, not as matter, but as memory. Perhaps the universe will remember its own awakening and smile in the only way it can, through the continuation of rhythm, through the persistence of balance. And though there will be no eyes left to see it, no ears left to hear it, the music will still play, quiet and complete. So rest now. You are part of that rhythm, a small movement within an infinite song. Let your thoughts drift like galaxies, your breath expand like space itself. The universe will carry on. And so will you, in one form or another, within the timeless harmony of all things. Close your eyes, feel the motion beneath stillness. Feel the presence of dark energy, soft, steady, patient. It has always been there, and it always will be. The song continues, forever.